Okay, good day, ladies and gentlemen. So, for the next couple of weeks, we're going to start looking at digital data and how they are stored and manipulated within our computer systems. In this video specifically, we want to understand that media is stored as binary data, and I'm going to introduce a new concept called hexadecimal numbers. So, when we look at today's computers and think about their media, we have many different types of inputs into our computers, same as many different types of outputs into our computers. We have text data, so this is not just texts that we're sending from our phone. This is when I press the keyboard, or if I send an email, or any data, any media that's really represented as a string of characters. Okay, so that's text data. And then we have images that we are recording from our cameras. We have audio that we're recording from our microphones. We have video, which is really a combination of image and audio. We have computer games. There's a whole host of media that our computers are able to store. Okay, but they don't store them as the media. You know, that when we give a computer an image, it's not stored as an image. What happens is that it gets transformed into a series of bits, zeros and ones. Okay, and we've talked about this in hardware and earlier on, but I'm really just going over this again here. But essentially, whatever media we are giving to the computer, or in fact whatever information we give to the computer, it is all transformed into zeros and ones and stored in that computer. So in this module, what we're going to look at is how do we transform that media into binary so that it can be stored, manipulated, and output by different computational devices. Okay? So I was at a dinner party a couple of weeks back, and actually somebody asked me, why do computers use binary? Now, being a computer scientist, I love this question. I spent 20 minutes explaining about transistors and the beauty of binary manipulation and bit shifting, etc., etc., etc. And I guess at the end of it, I'm never going to get invited back to that party. However, what I should have just said to the guy who was asking the questions is that computers use switches to remember data. Okay? That is why computers use binary. So we have zeros and ones because at the hardware level, the processor and the storage systems, they're all using switches. Okay? A switch is either on or it's off. So all of the things that we send to a computer has to be converted to some method of switches, either on or off. Okay? Computers use binary because everything is a switch inside the computer. Now, because computers use binary, zeros and ones, and then we have to be able to manipulate those zeros and ones, this gives rise to an idea called number systems. Okay? Now, number systems describe how to count. Now, we use a number system every single day called the decimal number system, because the decimal number system is base 10. All right? It uses the digits 0 to 9, and each column that we write is a power of 10. So if I were to write, let me just grab my laser pointer. So if I were to write 101 and I'm using the decimal system, what that's really saying is I want 1 lots of 100, 0 lots of 10, and 1 lots of 1. Okay, which is 101 as we know it every day. Okay, so the decimal is what we use every single day. That's the number system. Now there's a second number system that we can use, and we've started to use, called binary. Right? And this is base 2. It uses the digits 0 and 1. And each column is a power of 2. So you know that when we're doing our converting numbers from decimal to binary, and we have 1, 2, 4, that's because 1 is 2 to the power of 0, 2 is 2 to the power of 1, 4 is 2 to the power of 2. Okay? Next one would be 8, 2 to the power of 3. So when I write 101 in binary, what I'm saying is give me 1 lot of 4 plus 0 lots of 2 plus 1 lot of 1. So 101 in binary is the same as 5 in decimal. Okay, that again, we've done this. This should all be very familiar to you guys. The third number system that computer science uses is called hexadecimal. So hexadecimal is base 16. That means that we have to use 16 different digits. Now, in our alphabet, in our character systems, there are only 10 numeric digits, 0 to 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. So if we're going to use 15 digits, we have to borrow from the alphabet. So the way that hexadecimal works is it says 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. Okay? And we'll talk about that a little bit more in a second. So it's base 16, so each column is a power of 16. So 101 is 1 lot of 256, 16 squared, plus 0 lots of 16, plus 1 lot of 1. So in hexadecimal, 101 is 257 in decimal. Okay? So, as I've said, hexadecimal has 16 digits. It goes from 0 to 15 in decimal, and then here's the corresponding hex digits. So 0, 1, 2, 3, 4, 5, 6, all the way up to 9. And then we say A, B, C, D, E, F. So F in hex is 15 in decimal, and then F plus 1 would take us to 10, to 10. Okay, so this is hexadecimal. So if I have 9 hex plus 1 hex, so 9 hex plus 1 hex is 10 hex. The H at the end of it character just tells us whether we're dealing with decimal, binary, or hex. Okay, F hex, FH, so that's 15 in decimal, plus 1 is going to give me 10 in H. Okay, in decimal, 255 is the binary number 1, 2, 3, 4, 5, 6, 7, 8 bits. So binary is 8 lots of 1s. In hex, it's FF. We'll talk about how we do the conversion later. All I'm doing at this point is just introducing you to the idea of hexadecimal. Right. In the next video, we'll talk about how you convert between the three of them. The usual question is, this looks massively confusing, sir. Why do we use hex? Well, the truth is, it's actually easier to use when you start using when you start doing binary numbers. And once you see how we use hex, you'll see why. Large base sizes, so a 16 is actually easier to type in than small base sizes. Bearing in mind that the computer only understands binary. If I wanted to type in 255, I'd have to type in 8 lots of 1 and then B. Or in hexadecimal, I can type in FFH. So you can see how that's much easier straight away, right? Rather than typing in 8 ones, I can just type in 2F. It is, in fact, incredibly easy to convert between binary and hex, and we'll talk about that later on. And hex is more efficient than decimal because, again, if we were to have 255 in decimal, well, that's 3 keys, or in hex, it's 2 keys. Okay? So that's why we're using hex in computer science. Now, you may have already seen hex in computer science. We haven't done a lot of machine code or assembly languages, but when we come onto that, you will see them. We use hex all the time. But you may have already seen when we're doing colors. So rather than web colors tend to be represented in hexadecimal. So you might have seen colors being presented as FF for white, or maybe FF0000 for red. Okay, so where we're typing in FF, that's because that's actually the hexadecimal version of 255. Okay, so you might have already seen those colors when we were doing the web already. So, like I said, all I wanted to do in this video is just to remind you that everything inside the computer is bits, zeros and ones. No matter what media we give it, image, sound, video, text, doesn't matter. Everything inside the video is zeros and ones. So everything inside the computer is zeros and ones. Then I wanted to introduce you to this idea of hexadecimal, just where we're counting from 0 up to 15, using hexadecimal characters. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. And then one more means 1, 0. Okay, that's the end of this video. If you have any questions, don't hesitate to contact me, and I look forward to seeing you all soon. Take care.